All right. So what we're going to do here is we're going to talk about the 5 different categories of chemical reactions. So the first one we're going to talk about is a synthesis reaction. In a chemical reaction, we use a chemical equation, and our chemical equation, we will show you again here, is A plus B yields AB. So it says, so this is a generic formula for a chemical equation for synthesis. So two or more reactants. There's two reactants. The reactants on this side yield a single product, and this is the product side. Here's an example of a synthesis reaction. Hydrogen gas plus oxygen gas gives you water, a compound. So these are two elements, two molecules. You can ignore the coefficients here, so it may make it easier to see that that's A, that's B, and that's a single compound here. You could also have a compound and an element to form one single product. You can have both, and I'll show you an example of that. But this is how they look, and you're trying to identify these. So these are not balanced, but you can see if I give you the form A plus B equals a simpler product A, B combined. So this would be your A, an element, another molecule, and then combined your products here. So reactant sides, product side. Reactants, products. Simple combined to make a compound. So let's balance these off. So we have, in this particular case, we have, so if I look at my K's and my CL's, right? Separate these. On the reactant side, I have 1 and 2. On the product side, I have 1 and 1. So because the chlorine is heavier on the reactant, we're going to make the product size bigger by 1, or make this go into a 2. We change how many we have here. We have 2K and 2Cl. So that makes this balanced, but we need to make the potassium go to 2. Same here, phosphorus and oxygen, phosphorus 4, phosphorus 2 here, oxygen 2, oxygen 3. All right, so let's start with the phosphorus. If I double that molecule, use the coefficient 2 as the coefficient's all I can do, that makes this 4. Good job, we're balanced on the phosphorus. But this makes us also double the amount for 6. So let's go ahead and 3 molecules of oxygen, 3 times 2 gives me 6. And then we're done in that balancing act, I guess we call this. All right, so if I choose which is an example of a synthesis or combination, A, B, or C, you make your choice here and give you an opportunity to take a look and see if any of these fit a single product. Here's the product. Simple materials,